So there's three words I want to talk about first. The first being equal. This is a word that you see all the time, you're very familiar with. And you know that when we say two things are equal, it means that they have the same value. 2 plus 3 is the same. It's worth the same. It's equal. It's equivalent to 5. Now congruent, which we use the equal sign plus a little squiggly line on top, it basically means equal to, but this is in the context of geometry. So when we say two things are congruent, we're basically saying that they're the same shape. Same shape and the same size. Same everything. It's just basically saying two shapes are equal. But I want to introduce a new word, similar. And I use the word similar a lot in daily language, basically meaning that two things are kind of the same. And we mean it somewhat like that in geometry. The symbol for similar is just the squiggly line. And when we say two shapes are similar, we mean that they're the same shape, but they're different sizes. So similar means it's the same shape, just a different size. And if it's the same shape, then that means that these angles are going to be the same. And I'm just putting these little lines in here to show that that angle is the same as that angle. I'm going to use 3 lines here and 3 lines there to say those angles are the same. So similar shapes have the same or equal angles, but their sides can't be the same shape. They're different sizes. What we say is that their sides are proportional. So same angles or equal angles and proportional sides. Coming back to congruent, congruent means same everything. So we got same angles and congruent shapes, and we got same size and congruent shapes. Everything is the same, and I could put lines all over it, doesn't matter, they are all the same. Alright, whereas similar, same shape, just a different size. Now what do we mean by proportional? What are proportions? Proportions, or we also use the word ratios. Proportions are basically a relationship between a part and a whole. Okay, basically a relationship between a part and a whole, and that's kind of vague. And I'm going to show you some examples to show you what I mean by this. But I have lots and lots of examples here to show you basically two things. One is that proportions are super useful and super relevant. I mean, I probably use proportions more in daily life than any other probably math I've ever learned. They're super, super important. But also, you'll see there are many ways to think about and solve proportions. We don't all have to do it the exact same way. There's a lot of different ways to solve it if you understand it. Now let's look at the examples. Can I get this question all the time? I made a 42 out of 50 on my quiz. What's my grade? And this is something that we should be able to figure out on our own. This is something you learn how to do probably in the 7th grade. Maybe you breezed over it and didn't fully understand it. But my hope is that you understand these concepts right now. So if you made a 42 out of 50, you're wanting to know what is that out of 100, because everything we grade is on a 100-point scale. So we set up a proportion to say, well, I made 42 out of 50, what would I make out of 100? Now many of us, we can just do this in our head simply because 50 times 2 is 100. And then 42 times 2 would be 84. And so your grade really is an 84, an 84%. There's another way to solve this, though. And you probably know, as whenever you see this proportion or this ratio set up like that, you maybe automatically think, oh, I can cross multiply. I can take that times that and that times that. Sure you can. Okay? 42 times 100 is 4200. And 50 times x is 50x. Now, in this case, it doesn't make a whole lot of sense to cross multiply because you end up with these big numbers, and even I'm not, would have to think about that, doing that in my head when you divide by 50. We already know the answer. But in this case, cross multiplying kind of makes it a little bit more difficult. So it's good to know a variety of ways to solve this problem. But when you divide both sides by 50, you'd get that x is 84. Okay, another way, I'm just going to show you a third way, is 42 out of 50. We could break down, and if you have a calculator, you can divide 42 by 50. And if you put that in a calculator, you would get 0.84. And so then you have, and I'll come over here so I have some room, is you have 42 divided by 50 is 0.84 equals something out of 100. And then if we times both sides by 100 to get x by itself, we get that x is 84. Okay, so 3 different ways to solve the same problem, but the basic concept is that these two things are proportional. 42 out of 50 is the same thing. It's proportional to 84 out of 100. Another example. Let's say you make 5 out of 10 free throws. Maybe you're Sean, and you struggle with your free throw shooting, and so you only make 5 out of 10. You know, if you're Mr. Rooney, you'd make 10 out of 10. But Sean is going to make 5 out of 10, and we want to know how many Sean's going to make out of 80. Again, there's a couple different ways to do this. You may look right off the bat and say, okay, well, I know that 10 times 8 will get me 80. And so 5 times 8, I'm just going to erase the x. 5 times 8 is 40. And so he would make 40 out of 80. Or you could say, well, 5 out of 10... that's 50%. That's half. He's made half of his free throws. And so, keeping up with the proportion, he would have to make half. 40 being half of 80. Same idea, same answer. Just looking at it a little different way. Again, you could have said, like we did before, you could have cross multiplied and did 5 times 80, which is 400. 10 times x is 10x. And then divide by 10 to get x is 40. You could have also, like we did the last problem, and said, 80. 5 out of 10, you put that in your calculator, you get 0.5. That's kind of what we were doing earlier when we said it's a half, 0.5 being a half. And then if you times both sides by 80, you get 40. So we've done the same problem 4 different ways, which is a cool thing because all of our brains think differently, and so hopefully one of these ways will kind of make sense to you, and you can get the hang of these and become experts at proportions, because it's super useful stuff. Another example, costs $12 to fill up 3 gallons. So it costs us $12 to put 3 gallons of gas, should have put gas in your car. How much is it going to cost? I notice I lined up the money with the money and the gas with the gas to fill up 12 gallons. Again, there's 4, probably even more ways. Maybe you can come up with another way that I'm not thinking of to figure this out. And I don't care which way you do it. Me, I just kind of look at it and see what's easiest. And what I notice right off the bat is that 3 times 4 is 12. 12 times 4 is 48. Okay, I'll look at it one more way. You may have noticed that 12 divided by 3 is 4. So might have noticed right away, we're getting $4 for every gallon. So if I'm getting $4 for every gallon, 3 times 4 being 12, 12 times 4 is 48. I'm going to have to spend $48 on 12 gallons because every gallon is $4. Okay? Either way, these are all proportions. These numbers are all proportional to each other. Example 4, it takes 3 hours. I just write hours so I can match things up to drive 200 miles in the car. How long is it going to take to drive 1,000 miles? Okay, again, I'm just right off the bat saying I'm noticing that 200 times 5 would be 1,000. 3 times 5 would be 15. So I know that this is going to take me 15 hours to make that drive. You could have, maybe you didn't notice that. Cross multiply. 3 times 1,000, 3,000. And 200 times x is 200x. I generally don't like to cross multiply because you end up with these big numbers, but sometimes you have to because things don't go into each other evenly. But then divide by 200. If you have a calculator on hand, you get, again, x is 15. Okay? They're proportional. Let's look at a few more. 20% tip on a bill. Now this is slightly different, but it's the same idea, and it's very practical. You're going to have to do this. And you get good, you can do it in your head. I know there's an app on your calculator, but what if you don't have your calculator or your phone or whatever? Plus, it's good to be able to do math in your head. We got a bill that's $30, and we're giving a 20% tip. Now this percent, take a slight detour to show you this word per cent. Cent coming from the word century or centipede or centimeter. Basically this means 100. So when we say percent, we're literally saying 20 per cent or 20 per 100. So 20% is really 20 out of 100. Is really what that means. 20 out of 100. It's a ratio. Percent is just a ratio. 20 out of 100 is what out of 30? We want to know 20% of 30. We got the proportion set up. Pick a way to solve it. It doesn't matter. I noticed that 20 times 5 is 100. So this is a fifth. And so 20% is going to be a fifth of the bill. And so I would just divide 30 by 5 and get that x is going to be 6. So we would leave a $6 tip. Okay? There's a couple other different ways to do this. 20% is the same thing as 0.2, like we did up here. Just 20 divided by 100 is 0.2. And so then we can just do 30 times 0.2, and we get 6. Okay, same answer. What I like to do in restaurants is just take 10%, which is always easy because you just move the decimal place over, and then times it by 2, because you're not giving 10%, you're giving 20%. But whichever way, we could have cross multiplied, it doesn't matter. You're going to get 6 all the same. Alright, looking at a little different problem. We're going to the grocery store, and I do this all the time. We're buying Mario sauce, spaghetti sauce, 20 ounces. Cost $3.60, and Luigi sauce, if you get 16 ounces, it costs $3.20. Okay, we want to know what's the better buy. Well, here this is a slightly different problem, but it's still a proportion problem. Is we want to know the unit price, and grocery stores now have where they write the unit price for you to help you out. But this is what they're doing. Is saying, okay, well, 20 ounces out of 360 is how much is that costing per 1 ounce?